Hello, class. I wanted to finish up section 1.3. So let's just kind of take a look at the few examples we have left. So starting with this one, we're going to want to use the distributive property, distribute those values through. So I end up with 6 times negative 5i here plus 6 times positive 5i minus 25i squared here. All right, so at this point, these two cancel. And I have 36. Now, we're going to do minus 25 times negative 1, or 36 plus 25, which is how we get 61 there. Keeping in mind that I squared is equal to negative 1. Talk a little bit about conjugates. If we have a complex number z equals a plus bi, then the conjugate is going to be z bar or a minus bi. And that's the relationship between conjugates. Examples. 1 plus 2i, its conjugate, 1 minus 2i. 2 minus 4i, conjugate, 2 plus 4i. What about 6i? Its conjugate is negative 6i. Now, how did I get that? Well, 6i is 0 plus 6i. So then, let me not go that way. So then from there, we get 0 minus 6i, which is how we arrive here. Now, with quotients, you need to multiply by the conjugate. Well, both the numerator and denominator by the conjugate. All right, so what's the conjugate here? It's going to be 5 plus I. Multiply those two together. Let's start with the bottom. So I'd get 25 plus 5i minus 5i minus I squared. Those would cancel. In the top, I get 15 plus 3i plus 10i plus 2i squared. Let's simplify the denominator. That would be 25 minus negative 1, or 26. In the numerator, we're going to end up with, this is going to be 15 plus 13i, and we would have plus 2 times negative 1 there. So 2 times negative 1 is negative 2, plus 15 is 13. 13 plus 13i. Now you can leave it like this if you, well, you can't leave it like this. But what I'm saying is like the arrangement where the numerators are over one denominator. But what would probably help you is if you wrote them over each denominator. So like, or each of them over their own denominator. Hopefully that will help you see that this is 1/2 plus 1/2 I, or you have the option that you can just factor out a 13 here, which will cancel with the 13 in the denominator. And you'd be left with 1 plus I over 2. So you can express it like that, or, you know, you have the option to express it like we have there in blue. This one always throws people off, but it's about remembering that the conjugate of I is negative I. So I get negative 3i over negative I squared. So I'm going to get negative 3i in the numerator. Negative I squared is minus 1. So I'll just end up with negative 3i here. Now, powers of I. So there are 4 things we should keep in mind, and these 4 will help you keep up with what you have going on with these powers. So I is just negative 1, I squared is negative 1, I cubed. Now, if you break this up, I cubed is I times I squared. What's I squared? It's negative 1. What's I? It's the square root of a negative 1. This can also be written as negative I, just kind of depending on what you're using it for. So these two will probably be what you do, but I want you to just kind of take a look at how you can split up these exponents using the product rule. All right, now I to the 4th is I squared times I squared. Now what's I squared? Negative 1. Negative 1 times negative 1 is positive 1. So using those 4, we can reduce the powers of I. For example, I to the 15th. Something that Andrew pointed out is that you can kind of just count them, and that's true. So we can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So then I cubed, I to 15th is equal to I cubed. Now maybe that doesn't make sense for you, so I'm going to help prove that this is the answer. Well, I to the 15th is technically I to the 12th times I cubed. I to the 12th can be written as I to the 4th cubed. What's I to the 4th? It's 1. 1 cubed is just 1. So we just have I cubed here. Now we can express this as negative I, or we can express this as negative square root of negative 1. Now some folks are asking about negative powers. I to the negative 13. Well, what you're going to want to do here is multiply. You want to multiply I to the 4th by this value until you get a positive number. Now, if we did that just one of them at a time, it would look like this. Now negative 13 plus 4 is negative 9 times I to the 4th. And you can keep doing this over and over because I to the 4th is just equal 1. Negative 9 plus 4 is negative 5 times I to the 4th. That's negative 1 times I to the 4th. That gives me I cubed, or negative I. Now there's another way we can do that, and that's just to multiply by powers of I to the 4th. So, and what I mean by powers of I to the 4 is if I have I to the 4th and I raise it to the 3rd power, I actually end up multiplying the exponents. Oh, excuse me. I actually end up multiplying the exponents here. So every time I raise the power of I to the 4, I get another 4. So the next power of I to the 4th, so I to the 4th to the 4th power would be I to the 16th, all right? And that's what we would need to multiply this by. So I have I to the negative 13th. If I multiply this by I to the 16th power, and you're wondering why I to the 16th. So I'll multiply this by I to the 16th power. What this is, I know, is, right? I to the 4th to the 4th. All right. And since I to the 4th is just 1, 1 to the 4th power is also 1. So we can do this. So what ends up happening here, we add the exponents. So that's negative 13 plus 16, or I to the positive 3 power, which is now where we can simplify our situation. And that's pretty much how you resolve powers of positive and negative. And this way will work, at least with the I to the 4th, or splitting them up into powers of I to the 4th. So for the positive, you need to kind of split it up like we did here. For the negatives, you need to multiply it by a power of I to the 4th in order to kind of cancel those out. So even if you have like a power of 101, you can still use this process and determine that. And that's it. I hope you all have a great day. Thank you. Peace.